Hello, my name is Sungmin Cho. Let me introduce the paper PaLI, a jointly scaled multilingual language image model. Currently, increasing neural network capacity has been a successful trend in both unimodal and multimodal side. Most of our large models have shown significant advantages from the largest set of training data and over 1 billion parameters. On the language side, T5, GPT-3, PaLM, and lots of such models has been proposed. They have parameters of at least 10 billion and in some cases close to 500 billion. On the vision side, the models like CNN and VIT have been similar benefit but not effective as language models. Also, on the multimodal language and vision side, there are several models increasing scales of neural models. The proposed model, PaLI, Pathways Language and Image Model, starts from making full use of advantage of these trends. The pre-trained large-scale neural models have achieved outstanding performance on each language and vision side, so exploiting its full performance on multimodal and multilingual text is our main target. So we use two models, MT5 and fine-tuned VITG on multimodal text. But there is an important question, how to jointly scaling both two components, so we suggest two answers. First, we propose a simple modularized and scalable sequence-to-sequence running architecture. This architecture is balanced parameter share between the language and vision components. Also, this architecture is appropriate to use large unimodal backbones. Also, we frame all text including vision only, language only, and vision language as image plus query to answer string modeling interface. This makes the model to capitalize on transfer learning across texts. Also, it makes the model not forget its pre-trained rich knowledge from unimodal backbone. First, I introduce PaLI's architecture. We design simple architecture for processing multimodal inputs. PaLI uses a text encoder-decoder transformer with vision transformer for processing image input. We aim to perform both unimodal and multimodal texts. So we resolve this by using a general interface for all texts considered. The model accepts as input an image and text string and generates text as output. The model does not need text-specific parameters or heads. We use text-based prompts to indicate to the model which task to perform. For the visual components, we train the largest vanilla VIT architecture named VITE. VITE has the same architecture and uses the same training scheme as VITG model while scaling to 4 billion parameters. The difference with VITG is applying running rate cooldown twice and averaging the weights of the two models. VITE can achieve substantial performance gain on visual language tasks in PaLI. Finally, we adopt the MT5 backbone as our language component. Also, we fully exploit LM's language understanding generation abilities with training on a mix of many texts, including pure language understanding tasks. For training larger models effectively, the larger datasets is required. However, currently there is no vision text dataset which is large and multilingual. I introduced PaLI, a multilingual image language dataset built from images and text available on the public web. It scales up the image language data collection to 109 languages and contains 1 billion images and 12 alternative texts. For training with larger datasets, we use 8 training objectives. Our goal of training is to accommodate diverse tasks in image text and not forget pre-trained model's ability. So we train with multimodal text only and image only objective. I evaluate fine-tuned PaLI checkpoints on multimodal text and image text tasks. First, for image captioning, one of multimodal text, PaLI outperforms the latest data. It showed better results than the performance of the model trained on a larger scale. Even in the multimodal image captioning text, it showed much better performance. Then for vision question answering, PaLI outperforms against the SOTA models on both monolingual and multilingual settings. Finally, we verified whether PaLI can be applied to unimodal texts. The table above is the result of NLU benchmark and the table below is the result of image classification. Thank you.